Lesson 9.3, Multiplying and Dividing Rational Expressions. Now this one's a nice lesson because you're talking about doing two different things, multiplying and dividing, but with one simple fix, you're essentially doing the same thing in both cases. Alright, so first of all, let's look at multiplying rational expressions. So you have an example right here, okay, of multiplying basically two fractions. When you multiply them, it's top times top, bottom times bottom, straight across. Okay, that's how they get AC over BD. And if something can cancel, we'll do that. So here, again, notice top times top, bottom times bottom. In this case, they just wrote it out like that. They actually didn't distribute. Again, the same rules apply. You cannot have a denominator of 0 or anything that you could plug into x to cause the denominator to be 0. Now I'm going to do something right away. Okay, I'm going to tell you that multiplying fractions like this is what we just did. If you're dividing them, so if I had a over b, you know what, I'm not even going to do that. I'm going to take you right to it first. This is an overview. Now notice this one, it's a over b divided by c over d. Now the last one was multiplication. Alright, so look what we're going to do. We have to take this division problem and we're going to change it into a multiplication problem. And the way to do that is one simple step. We take the second fraction, the one we're dividing by, and we're going to change it by flipping it. In other words, making it a reciprocal. So c over d became d over c. Now notice the first one did not change at all. It's still a over b. So to change a division of rational expressions into a multiplication problem of rational expressions, it merely means changing the division sign to a multiplication sign and flipping or making the reciprocal of the second fraction. And then you can go ahead and approach it like you did the first examples of multiplication. Top times top, bottom times bottom. It's a quick fix. And it's very important because this little step causes great headaches for a lot of people that are not comfortable with math. Even though with one little fix, they can actually get through it quite easily. So let's take a look at some examples. Here we have a multiplication of two rational expressions. So what does that mean? It means we multiply. We'll multiply top times top, and we get 12. Bottom times bottom, and we get 40. X, so here's your rules of exponents. We're multiplying bases, so the exponents get added. X to the fifth. And just like before, we should simplify. So 12 over 40, we have 4 can go into each, so 4 goes into 12 3 times, 4 goes into 40 10 times. So our final answer is 3 over 10x to the fifth. Are they asking for excluded values in this case? No, but if you were asked, the excluded value would be 0. We cannot plug a 0 in. Next one. Now I'm going to do something here first instead of doing it second like I did in the previous question. I'm going to just multiply across the top, right? So it's actually like they were put together. I could write all of this as one fraction if I wanted to, because you're just multiplying top times top and bottom times bottom. But let's look at it this way for a second. If that's the case, and everything's being multiplied, then we can cancel out right away. So I'm going to take out 3n plus 7 and 3n plus 7. They're in parentheses, they're locked together, so I can do all of that. I have a 5, and I'm going to choose to cancel it with this 5, even though I could cancel it with this one. It's up to me. But I cannot cancel with both of them. I have n squared, so I'm going to take away that n squared. So what I'm left with is 5 n squared, that's the only thing left on top, over 3. Now there's no variables in the denominator, so there are no excluded values. There's no way for me to cause the denominator to be 0 by plugging something in because there are no variables. So this would be my final answer for that one. So let's take a look at the next one. Again, we would multiply across, but notice that this piece right here is in non-factored form. It's a trinomial. So again, I can only factor when things are multiplied. So let's factor it. We have an x, an x. We have factors of 12 that add up to 1. Actually, factors, the product's a negative 12. So factors of a negative 12 that give you 1. That'd be 4 and 3. And the 4 would be positive. Alright, so this is now gone. So again, we talked about this as being, we're multiplying, so everything's on the top, they go right next to each other. And they're being multiplied, which means this has parentheses, it's being multiplied by the top of the other one. The bottom one is being multiplied by the bottom of the other one, so I can write them in parentheses. But it also allows me to cancel. X plus 5, x plus 5, x minus 3, x minus 3. The only thing I'm left with is an x plus 4. Now notice that there are no denominators here. I could write it over 1, but I don't have to, which means again that there are no excluded values. Next, notice we have again k plus 8 is in parentheses times the top of the next one, which is not factored. So let's factor it. I can take a 6 out, which gives me k minus 1. Now why do I factor? Because maybe there's something else I can cancel. The one underneath that has a 6 in common. If I take that out, I get k plus 5. Next one's a trinomial. So we get k, product of negative 2, sum of 1. So it'll be 2 and 1. And I would need a positive 1, so the 2 is positive, and the 1's negative. Now again, I've created a multiplication problem right there, but multiplying them together will cause the two denominators to be multiplied, same with the top. So now I can cancel, if there's anything to cancel. Well, I notice that there's a 6 and a 6, a k minus 1 and a k minus 1, which gives us a k plus 8 and nothing on the right side of the other one. In the bottom we have a k plus 2 and a k plus 5. So this would be considered factored. Now again, if they asked for excluded values, we'd have to say this would be negative 2, this would be 1, and this would be negative 5, if they asked for those. In this case, they do not, so we'll leave it at that. But good to keep in mind. Now, the division part, as I mentioned earlier, should not throw a loop at us or a curve at us. It makes us add a step, but it should not be more difficult. For example, in this example they give us here, notice the second fraction, you're dividing by this fraction or this rational expression, and then in this piece, it's been flipped. It's the reciprocal. The first one did not change. That one stays the same. It's the second one that flips. And then you go on from there like you did before. So first one here, we have 5a over 8. So 5a over 8. Alright, now I can make that a times if I change the second fraction to 8a over 9. Okay, so all I'm doing is reversing the second one. And then I can change it to times. So I took this piece and I made the reciprocal of it. And then I would go from there. But again, before I go ahead and multiply, I'm going to try and cancel. So my 8's can cancel. I'm left with 5a squared over 9. Okay, next one. Next one would be 15y squared move it up here. 15y squared over 4x And I'm going to make it multiplication by taking the second fraction and making the reciprocal. And that would be it. Meaning, I shouldn't say it, but that makes it a multiplication problem. So now I have multiplication going on. So I took this piece and I reciprocated it. Now again, multiplying top times top, so I'm going to cancel right now. I have a y right here, I have a y squared, so I'm going to make that a 1. I have an x here, and I have three x's up here, so if I take one away, I have 2. I have a 4, can go into 4 once, 4 can go into 8 twice, 5 can go into 5 once, and 5 into 15 3 times. So I would end up with 3y, or I'm going to write the x term first, sorry, 3x squared y. Denominator is all 1, so that's all I got. Again, if they ask for excluded values, I'd have to plug in a 0 for x and a 0 for y. That would cause it to be undefined, so I would say excluded values are 0. Okay, a lot more factoring in place here, so keep that in mind. So we have, now I'm going to do this first. I'm going to say 4 over x minus 3, and then I'm going to flip the other one right away. And I'm going to flip it and factor it. So I'm focusing on this piece first. Okay, I'm going to factor it. So, because I'm going to put that in the numerator so I can do multiplication. And that would be x. And factors of 30, they give me a negative 13, 3 and 10. So 3 would be plus 3. Nope, I'm sorry, I need a negative 3. And x minus 10. Now I'm going to factor the top one. I see I have a 3 in common and an x in common. So if I factor that out, I get x minus 10. Take a 3x, I should get x minus 10. Looks good. Alright, now what I've done here then is, I'm going to take this away. I've changed it to multiplication by making it a reciprocal. Okay, I took this and I swapped it. I reciprocated it. Okay, if that makes any sense, I flipped it. And now I can cancel. It's like one big fraction, top times top, bottom times bottom, so I can cancel if there's anything in common. My x minus 10s can go, my x minus 3 can go, and that's it. So we're left with 4 over 3x. Excluded values would be a 3, a 0, and a 10, if they cared. Next one, same problem, except I'm going to look at it a little bit differently, so pay attention here. I'm going to say 1, and I'm going to make this a negative n plus 3. So let's actually do this. Let's factor a negative 1 out, which makes it an n minus 3. Okay, so if I were to redistribute that negative 1, I'd get the same thing. Okay, now the next one, I'm going to reciprocate so I can make it a multiplication problem. So the top one's going to be the factored form of n squared minus 10n plus 21. So that would be product of 21, a sum of negative 10, so 7 and 3. So it would be n minus 7 and n minus 3 over n minus 8. I don't have to put in parentheses, but just so we know that it's the same thing, it looks a little more the same. And then we factor. So times, now we get n minus 3, n minus 3 is gone, and we're left with an n minus 7 on top. We're left with an n minus 8 on the bottom. But don't forget that negative sitting there, so I put the negative on the outside. I could distribute that if I wanted to, but this is good enough. Okay. And this ends lesson 9.3.